with the previous lectures that we had last week, I demonstrated us doing a little bit of static analysis using some hands-on tools. By which I mean some of the basic tools that are available in Linux, which is really how a lot of the kind of forensics works on a lot of teams. In this lecture, I'm going to actually introduce a few applications that exist out there that have been built for the purpose of static analysis. So they're the types of tools that you would take the information that you learned from last week and then plug it into signatures for doing malware analysis or malware detection in the tools that I'm going to talk about today. In addition to that, I'm also going to dive deep into one specific one that's really popular among the malware analysis community. But I'll talk right now about signature-based antivirus systems for a moment. So you've probably seen these, your McAfee vscan or your Norton antivirus from Symantec. Those types of tools are all generally considered to be signature-based antivirus, or more recently, some of them have started to introduce a few other features as well, but they are all rooted in decades-old, antivirus technology that's based upon signature detection. So that means taking all those visual characteristics or all those observable characteristics we pulled from like the last week of toying around, and then writing large signature databases to scan your files against. So for instance, whenever you download stuff from the internet, that type of thing, the tools that are running on your Windows system and even your Linux system and your Macintosh system may run through one of these virus scanners to check and see if it's actually something that's detectable by the database. In many cases, these tools end up being subscription-based tools, so you don't typically, as a user, get to analyze malware and then improve the functionality of like your Intel McAfee virus scan tool. You don't really have a way of adding to your own signature database, and that's kind of by design. A large number of these are signature-based. They make a large amount of money off of signatures, and they have a large staff of people doing that analysis work as well that they need to fund with that. But basically, that's kind of what signature-based antivirus systems. So the analysis work that we went through, and then identifying the unique characteristics of those files, and then documenting them, that is the cycle for a lot of the malware analysts at these companies. That's like the daily operation cycle. So we took some time to analyze both of these files. You'll remember the PDF file we actually analyzed somewhat blindly in the second week lectures. That was the one that was the evil.pdf that had that Metasploit backdoor or Metasploit exploit in it. You'll probably also analyze some PDFs for one of the homeworks that I assigned. In addition, we also looked at Win32exe DLL files. So from a Windows standpoint, the file content and format is the same. There's a couple flags in there that differentiate whether it's an exe or DLL, and that's how Windows knows to tell one or the other. But the underlying file structure is the same, so I put them on the same line because there's no real tangible difference between them. We did a bunch of analysis on those using both the exif tool and the obj dump tool, as well as the strings tool in one of the lectures. And then right here is a bunch of the information that we were messing with in that Python script to try and extract information from those tools, so structured information. So like I said, we're actually going to go and look at a handful of tools. So I actually just pulled a list of popular ones after doing some research. I found this blog post actually has a really good summary of all three of these tools. So it's worth going and reading that and reading what the author of that blog post thinks about each one of these, because they actually took some time to study each one of them. I have two, but by and large, the one that I'm most familiar with is the one down here. The ClamAV is probably the more popular of the three, and then the other one is appears to primarily be more of like a research or academic project. So I also just threw the logos down here, so you know if you go to the sites, you're in the right place if you see those. So vscan. I thought this one was interesting. I'm not really going to spend a large amount of time on it, but it is the simplest of those three. So it's the most, it's the most simple, and therefore it's easiest to try and say get started with. One complication might be that the language that it uses for the configuration file and some of the other code within the program is in Lua, but for the most part it's a C++ program. So, whoops. So, yeah, so this is basically the tool right here. So you can see it's basically a C++ program. How they have it set up is that when you run the program to go and scan some files, it'll load this configuration file. And this configuration file gives it a list of file names to match on, or I should say file name patterns to match on, as well as a list of what it calls sensors. And these sensors are really the broad kind of observations that the author of this has made from analyzing a bunch of different types of files. So, for instance, this right here, you might recognize this as being the script tag in HTML, if you're familiar with HTML. So the person who wrote this determined that any pattern that matches this right here is very likely, or is a very common occurrence in bad HTML files, or HTML files that have malware inside them. Likewise, there's a number of other things as well. Here's some JavaScript code as well that they're kind of looking out for, and they wrote some signatures for. So these are very basic signatures. I will say the language that's being used here is actually this one. It's using a regular expression library. Let me see. Here we go. So this regular expression library actually describes the syntax right here. If you are familiar with using Perl or the Perl compatible regular expressions library, or using grep, for instance, the Unix tool, or if you've used like regular expressions in a language like Ruby or Python or Java, you've probably used a syntax that's very close to this. There's a handful of differences that are very minute, mainly stuff like this, where in order for the RE2 library to be more efficient in certain use cases, they eliminated some features that are common in a lot of other regex implementations. So this, this tool, for lack of a better term, the author of it primarily uses it to try and scan text-based files, so source code files, documents, things like that, so that they can look for really common, really common malicious characteristics that they've come across. And then they basically put it into these different patterns here. So for instance, in this case, this is basically, looking for the word unescape, followed by a open parentheses, followed by any number of things that's not a close parentheses, followed by a close parentheses. So basically, anybody attempting to call the unescape call in a certain way, that gets flat. That's what this thing's looking for. So as you can tell, this is a really short list. It's based upon this authors, or possibly the team of authors, personal research into a really small set of HTML malware. And so this database that they're providing here, it's nice and small, which might be very advantageous for you from the academic perspective, or from like as a research tool or learning tool. But it's not very good from I want to deploy this on a network so that I can actually use it to defend my network type of thing. The intelligence that's in here is not very broad. So I mainly bring it up to kind of show you a small tool that if you would like to look into the source code for something, this one has a number of components to it that are written in C++. They're highly readable, and so it makes a really good academic example. Now, I won't really touch on that one. This is about the only time that you'll see it in class, unless you look at it on your own. So ClamAV is actually one that's been around for a really long time. So as far as I can tell, I can remember installing it on systems that I was administrating back in 2004. So it's at least that old, and probably older than that. I wasn't able, in searching through the internet, to try and find a real date of the initial release, but it's been around for a very long time. Commonly, it's been applied, or I should say it's been installed on email servers, so any server that handles like your mailboxes and mail exchangers, stuff like that. And then also very commonly used in web servers where the web server is allowing people to upload content. Like if any of you have messed with Wikipedia or something like that and uploaded files to Wikipedia, upload images to Wikipedia, any system like that that allows anonymous users or allows any users to upload content in the form of structured files and stuff, it's very common to use this tool to scan them before it makes them available for other people. That way, you don't end up unwittingly allowing your website to be a publication site for malware. So this tool also has a number of command line programs that you can run. So the really basic one is what I've listed right here. So it's running this Clam scan against evil.pdf, which is the PDF document we made in week 2. So you can see that it properly identifies it as a malicious PDF, and it says that it has MS shellcode -7, so it must match against like maybe signature number 7 in there or something. So it has a signature database that has a whole bunch of patterns in it, similar to what I showed you in the other, similar to what I showed you when we were navigating through vscan stuff. But it has a much broader array of signatures that can apply to binary files and text files and pretty much any file format that that's really commonly used in email attachments. So like I can run this in the background, and then whoops. So there's that evil.pdf right here. So I can run clam scan evil.pdf to show you what's going on again. It'll take a moment. It has to build, it has to load that database in a memory that I was telling you about. So its database is a lot bigger than the other program you saw. So that's basically the same run that that you just saw me use earlier. I can also throw this, I can throw one of my lectures at it and see what it says about that. So basically it reports an OK. So what you would expect. One thing I will say is it's it's not comprehensive. So if I can remember, we have So I can probably take it and run it against this one. Let's see what happens. Let's see if it identifies it as malware or not. It may or may not. I don't know. Yeah, so it thinks it's okay. We will see what this thinks. So, I don't know. I can't make a determination based on what's in here. It does look like it has some XML in there that's probably for .NET code. I don't know, but so what I can do is I can try sending a number of them to it. So like this, into so, and then I can just do this. So I can try seeing if it'll scan a few of them. So you can do these kind of bulk actions with it as well. I'm just specifically taking the exe files that I have to try and see if maybe those will work against it. Yeah, so there we go. Now it's starting to scan some of them. You know, we'll see if it actually ends up identifying any file. I'll actually let this run in the background. And we can go back over the results later on. But, you know, as I said, let's see, did this one get it? Yeah, so here you go. See, that one found one. So as you can see, you know, it's not as, you know, this probably doesn't have as current up-to-date signatures as something else might have. But it's community driven and everything. And all of the signature information is actually freely available for you to modify. So if you really wanted to, you can go into the signature database and you could actually figure out exactly what this hit means as far as pattern matching goes. So go back here to this. So also, if you'll recall in the last week, we talked about generating a file digest or a MD5 digest or SHA-1 digest or SHA-256 digest. So basically a hexadecimal value to uniquely identify the files that you're trying to deal with. So you can keep track. I was using it more in terms of keeping track of your data type of discussion. This tool, this ClamAV program, actually allows you to build a database out of the list of those as well. So if you happen to, for instance, have a report malware link in your company or something like that, a very quick way to block at least that specific file from being used. And that's as helpful in the case where, say, an attacker sends the exact same attachment to, like, 80,000 people or something like that. This is valuable. However, I'd say it's probably among the least valuable of signature development approaches. And so because of that, ClamAV doesn't just support that mechanism. It also supports a pattern language, just like what I was showing you in that vscan tool. The vscan tool has a had a pattern language that you could use. So this one does as well. This one is a bit more cryptic. So I'm going to open this up over here. So if you go to their GitHub site, nicely enough for us, GitHub actually renders the PDF inside a window for us. They actually have information on how to create signatures. So not only do they talk through what I mentioned earlier, what I summarized, which was the digest hashes, which is right here. They also allow you to do what they call body-based signatures, which is if you take a input text like this, and then you write a hexadecimal conversion of it. And so they did a hex dump here using this sig tool, command line tool. I actually did a similar thing, and I'll go back over here and show you what I did. If you remember when we were looking through the evil.pdf, I'm going to turn the lights down here. So when we were looking through the evil.pdf, the PDF had a structure to it that was relatively easy for you to kind of look at and understand, or follow, I should say. But what happened was you kind of got down here, and then you ended up having what we determined was the executable code, or I should say the compressed code for the executable is buried inside of this block. And then after that, you ended up having, I'll show you, I just zipped to the end of the file. After that, you ended up having another object right here, so object 9. And object 9 actually had a bunch of JavaScript code in it that would try and get the Acrobat reader to actually do something, so execute code in JavaScript. So there's a whole bunch of things in here. From the signature development perspective, kind of my impression in analyzing this stuff was, hey, this JavaScript kind of references something in Windows System 32. It references a Spanish location for a template PDF as well as an English location for a template PDF. So it has all of this stuff in there that's attempting to do kind of language, language agnostic, at least between English and Spanish path names. But the one thing in here that doesn't seem to be translated very well, or it doesn't seem to be translated in two languages, is actually the dialog box text that gets popped up right here. So kind of what I thought that I do is just grab part of this text and make a really simple signature out of it for ClamAV. So what I ended up doing was I did the same thing they did here, it's just I used the hex dump tool. So if I go back here, what I can do is I can grab this text, and then I can which is the same as like this, right? Oops. We'll do it this way. So there you go. So it ends with like the 74 right here. This one up here ends with the 74. You have like 6963 right here. You have 6963 right here. So it's basically the same content, just provided different ways. One of the reasons they have this tool available is that it makes it really easy for you to turn that string that you saw. The other reason why I picked this string out is that if you recall that PDF, there was a specific exploit in there that this PDF was kicking off, and for whatever reason it wanted to pop up that dialog box in conjunction with the exploit. It's possible that other exploits in the future might also similarly use hard-coded embedded text like that as well. So I'm kind of writing a signature for it that way. So I grab that text, it's right here, and then I put it into a file which is this one. So what they call a logical signature database. They call this a logical signature. And the reason they call it a logical signature, I'm not going to go into all the features of it because I'm also not going to use ClamAV for a lot of stuff, but I kind of wanted to show you one of the most popular ones in my opinion that's out there that's used today that you might end up interfacing with. So the reason why it's called a logical signature is that this field right here actually allows you to reference multiple different contents. So for instance, and then the contents that you the different contents will be put in a list over here. So you'll have a list, something like this, right? So you'll have something after it. So this right here is actually, I grabbed this text. It's not exactly the same, but I grabbed it from that PDF as well using the same sequence of steps. But basically, I made my own database. So what I'm going to do now is I'm going to do clamscan-d PDF mal, and then I'm going to send it against my evil PDF. And then what it ended up doing was it found my signature, the one that I wrote, and then it also puts on official at the end of it to indicate that it's one of the ones from my rule set and not one of the ones from the official ClamAV rule set, which would help me in trying to differentiate if I'm doing something like this in the background. It allows me to very easily select the hits on my rule set out of this versus the hits on the rule set supplied by the ClamAV community. And so, as you can see, these things can end up getting very large. Let me see if we have a more so they probably, yeah, there's some more complicated examples in here too. So basically what ends up happening is you say what your signature name is, your target description block. Actually, I can't remember what I put for that. I just put the target ID number, and I'll show you what that means. That basically means like file type that you want this to apply to. Logical expression is actually a combinatorial, so it's you can use parentheses, and basically you can do sub-signature, so you can do indexes. So this one ends up being referenced as 0, 1, 2. So you can put in there like 0 and 1 and 2, or parentheses 0 and 1, parentheses, or 2, that type of thing. So you can do this logical arithmetic with the rules. So here's a good example right here on the inductive clause that it shows here. So I'm not going to go into a huge amount of depth with it, but it is worth looking into. So I actually have the data right here for that string match. So Yara, or I should say the Yara Project as it's typically referred to, is actually a much newer system than ClamAV. It was introduced as a project by a guy named Victor around, I think it was either 2009 or 2010, I can't remember exactly when. Since then, it's actually built up a large following of community support. So if I go over here, I can actually look for it right here, as well as, it's got a large amount of community support in addition to being owned by the VirusTotal site, which you saw in one of the earlier lectures. And that actually happens to be a company that was purchased by Google at some point. So it's basically part of the Google family of companies or something. This is the website for it. It's got documentation and all that stuff. It gives you a little example of the rule, of the rule language and kind of how powerful it is. And then you can go in here. You can see, you can see the contributors list is right here. So there's a large number of very frequent contributors as well as all of the, commits, and this ends up being, pull requests, etc. So 212 closed, and then if you wanted to, you could look across the different authors and everything too. So, this one's been extremely popular in the malware analysis community. Not quite as popular as ClamAV, in my opinion, in the detection and identification community. Usually, a lot of that's just because, as you saw, the ClamAV rules had a very strict, specific format to them, and they had a number of limitations about them. those limitations end up lending themselves to ClamAV being a very efficient, very fast scanning tool, but they do limit what you can do with it. So they limit the amount of complexity that you can encode in a rule set. However, it is pretty powerful, and in my opinion, Yara works extremely well both for malware research and analysis, as well as malware detection and alerting. I'll say that also one very common approach that many people use Yara for is, as you saw, I have that large zip file of like 10,000 malware samples or something that I provided on the provided through Blackboard to you all. That archive, if you wanted to, you could write malware signatures to try and look for particular malware samples in there. You can try and find out how many malware samples of a particular family are actually in there. That type of strategy is extremely common for Yara, and that was one of the earliest really popular applications of it. So that's kind of where I say it got a large amount of support in the research community, whereas ClamAV, this one has been extremely popular in the system administration, data management, defense area. So like ClamAV, you get a custom signature building language. Unlike ClamAV, the syntax is actually readable and arguably more flexible. I have a very narrow example right here that shows off the 3 different data types. So as you recall, with ClamAV, we were able to describe a file in terms of what its contents were using a hexadecimal string, or we were able to describe it in terms of what its digest hash was. In this case, we don't have the digest capability, but we do have the ability to use many different approaches to pattern matching for doing the detection, as well as a way to do combinatorials as well. So I'll go through this. One of the nicest things about it, in my opinion, is rather than you being restricted to having a specific name, which I put here at the top, for the rule file, like you did in ClamAV, where you just had one name that you had to try and be unique and descriptive with, you actually get the flexibility to put as many key value pairs here that are documenting metadata about the rule. So I've seen it very common for people to list all of the sample hashes in here that they've seen this rule catch on, or maybe the samples that were used in the development of this signature. I've seen people track the revision, the author email, the company it came from, people who run shared repositories on the internet, or I should say 4 people who run shared repositories where there's many contributors on the internet. This is very helpful because if you have a problem with one of the rules, or if the rule is detecting on a file and you don't know if that file is malware or not, it actually gives you a line of contacts to go and talk to whoever might have originated the signature. It also allows you to give a really detailed description if you want. So for instance, in this case, this rule has embedded in it detect evil.pdf sample from week 2 lecture, which is very specific and very descriptive. The other thing that you can do is you can look for data rather than having to convert all of my strings, so all of my text, into that cryptic hexadecimal format. I can actually embed the strings like this in raw, in plain text, and of course escaping certain important characters. So basically using the same language you use for strings in C++ or something. Likewise, if I want to, I can define a regular expression as well. So I can use a language that's very similar, or I can use pattern matching that's very similar to that vscan tool as well. And then finally, I can support the format that ClamAV supports. But this one actually allows me to go broader than just the ClamAV things, where in ClamAV, it allows me to substitute some of these digits with wildcards. I can do that in this as well, but I can also substitute them with certain ranges. So for instance, I could describe something in terms of that it is a string that begins with these 3 characters and then has anywhere from 100 to 150 characters between, say, another sequence of characters. So I can do all sorts of broad categorization like that. And then also I can define a number of other static strings, and I can set up a condition where if I want to, I can say, and this is using your standard logic. So if you're familiar with say logic class and any of that stuff, this should be familiar to you, just without the fun symbols. So basically, in order for this rule to match a file, either it has to have this text in it, or it has to have this sequence of bytes in it, or it has to match this regular expression pattern, or it has to have 2 of these strings in it, or generally 2 or more of those strings. So if it just has 1 of these things, it may not match. But if it has 2 of them, then it will match. So I can run this rule against, I'm going to get out of this. So here is my, I think it's called evil.yara. So here's that rule. I just pulled it out of the PDF. And so what I can do is I can run it against my evil.pdf. Oh. No, that's fine. So I don't, that's a warning. So the other thing that's nice about Yara as well is that the author of it has a large number of detections in place to identify when you might have written a pattern that could be inefficient. So it could be like highly computationally taxing, but not getting you any extra benefit from a detectability standpoint. So what they're telling me on this is that I probably want to change this from being the star to being basically a finite 0 or more closure on it. But it still ran. And what it did was it gave me a list here that's very easy to parse if you're a machine that says this rule name was detected, or I should say this signature was detected inside of this PDF. And then if I want to, I can actually get the details, which is what the S provides me. And you can see that it managed to match this number 2 a whole bunch of times, this number 3 a whole bunch of times, the cmd.exe it matched once, and the start it matched once. And then you can also see that this regular expression that I had it looking for, which I'll bring up right here. I was looking for if space exist, followed by anything, followed by template.pdf. And so that actually detected in a number of spots on here. So, and then this one down here. So if I wanted to, the other thing that's nice is that it also supports C++ style comments as well. Oh, maybe it doesn't. Oh no, I know what it does. I think it supports that style. Oh, it's mad. Also, I'll tell you why. The condition I have down here, I can't have any unreferenced values in this condition. Let's see. There we go. So it does support the C++ style comments. What it does not like is if you leave strings referenced in the condition that don't actually exist, that aren't defined. So when I took those out, now I just have a signature that looks for 2 or more of these things. So I can either have like 3 of that, right? So I can do that. This is, the same. I could break it up 3 ways. I can do four of that if I want. Likewise, if I wanted to, I could do 2 of, this is really just shorthand for doing this. So this is really shorthand for listing every single one of the indicators out by hand. If I wanted to, I could even put this in here. So if I wanted to, I could try this. Let me see. And it's not going to match anything because I only have 5 indicators in that list, so it's not ever going to match 6. So likewise, I could add one more. I'll just add random text, right? It also doesn't like it when you have a string up here that is not used in your condition, and it gives you an error for that because it wants you to remove that string from your rule. It sees it as wasteful. Yes.
Do you kind of feel like you're like if you're chasing? Like I feel like you're just discreetly kind of throwing one rule in and after another. I mean, I'm imagining someone who develops for this
yes.
for like a long time.
Yeah.
And like I would like personally to me, I just kind of feel like the solution is just like a temporary. Like I'm never going to catch the end of the rainbow,
yeah.
Right? Like,
yeah. So I'll say that this is not a solution. This is just one of the many ways that you have to attack the problem. The solution's really a lot more. Really a lot broader than this, and this is just one component of that solution. But yeah, that's actually very commonly what occurs if you go to, say, we'll say, whoops, it's fine. So I can go to this project, which is actually a public repository of Yara rules that's available. Let me see. Here we go. So this is literally a large pile of Yara rules, and if you go in here, guarantee you'll see, create this thing, update this thing, update this thing, and you can go in here, and I can look at the differences, and it's basically like, in this case, modifying it slightly, either to make it more detectable, or I should say make it detect better, or to make it, or I should say have higher fidelity, or make it detect something that it was missing before. This one too. So you'll see these things, and this is not too long ago. You can see somebody pushed a whole bunch of changes here. I think if I go here, it actually allows, or maybe it's this one, can't remember, commits. There we go. So you can see like all the different commits, like on a weekly basis, etc. So, this right here, holiday break, but you can see all these commits coming in. So every single day, they have, basically doing that. Like you're saying, it's what they'll refer to as whack-a-mole. So the goal is to try and come up with something that in a lot of cases doesn't result in you kind of doing whack-a-mole from the signature perspective. But
it just doesn't seem very I get this is a great tool for its purpose.
Yeah.
But every tool that I'm seeing kind of so far is nothing's dynamic about it, right? Like it's all like just one script written after another, huge amounts of contributions, like everything's hard coded damn near, except for like print statements. Like it's not really dynamic in the sense that it's not going to grow with the times unless you have 20,000 people.
Yeah, well, so that's generally speaking, that's how this thing tends to grow with the times, is that over time, kind of more contributors and more contributors and more contributors are using it. But like you're saying, I think we talked about it like a couple lectures ago, trying to find an approach that allows you to detect based upon how something's behaving or how network traffic looks, or maybe even using the characteristics of what systems are normally used by a group of systems in a given week or in a given month, or that type of thing. Trying to use identifying anomalies from that. So there's a huge amount of research going into that, and that's really what I would say is an emerging research field right now. There's a lot of tools out there that purport to do that, but a lot of them are very, very, very narrow in their applicability to any one situation. So trying to come up with something that,
universal
is one of those hard problems that basically is left unanswered today. It's just, good place to focus research. So kind of what I'm getting at this is, I'm diving into the rule description. Using the tool from the command line is nice. What I'm going to get into next is actually writing tools that use this as a component. So there's a C API to this one. So there's a library you can install, and it has a C API, which means you can include the header in C or C++, and you can basically write programs that use this language or use these rules for certain components within the program. So like one example of a good approach might be active network monitoring or something like that, or if you have like a constant stream of data and you're trying to do analysis on it, and you'd like to compare that analysis to a database or something like that using this tool, maybe you'd have something that would hook into the detection mechanism in it. So we can get into that stuff in a second, but at a minimum for the C API, and this is, I'll actually take a step back here for a moment. This is one of the nice features that Yara has that the other two projects I showed you don't really appear to have, is that Yara really is this library, this libyara. The thing I was running from the command line is really just a tool. It's a very small, like basic C program that just calls the library calls under the hood. But the library can also be installed in your system. And at a minimum, or if you want to create a basic scanning tool, a basic tool to leverage, say, Yara rules for some sort of purpose, you'd call like these for functions in sequence. So I have it giving the data types that they accept on the command line. So here, you'd create a new variable in your scope that's YR_compiler pointer, and then you provide a pointer to that pointer as the input to this, and then it'll malloc a new pointer, and then it'll overwrite your variable with the address of that pointer. Ditto with the add file. This is if I want to add a new file. So if I want to compile one of the rule files, I call this function. So I open the file using the normal C file commands, and then I pass that file to the compiler this way, and it compiles it, and then it stitches it into my rule set. So this one's nice because if I have a directory full of files, I can actually write code that goes across all of them. Or if I want the user to enter files on the command line for some reason, like for instance, I want to make an interactive like Yara rule teaching tool or something like that to a user, I could write that in this code. Let me see. Yeah. So, here I'll just go to the next one, and then we'll jump to demo. So basically, scanning involves creating your own custom callback function. So again, this concept might not be too foreign if you're familiar with event-driven programming. The Windows API is a really common place where this is done, where you pass a function pointer to various Windows event libraries, and then whenever Windows causes that event to happen, or whenever the user causes an event in Windows to happen, then your function is called and it's provided the context around that event. Same thing here, except while you're scanning your data, Yara will actually call your function and provide it information about the portion of your data that's being detected at the time. So generally the scanner will run until it's searched the entire buffer you provided, and it will call your callback function multiple times throughout that. When a rule hit occurs, you'll get the data passed into this message data parameter, and the data structure will look like this. What I usually end up having, I actually brought up, and I'll just look at it right here. It should be a Yara Chat.c. So, what I ended up writing, instead of it being a malware detection tool, I actually made it basically do some other functionality. So I made two rules inside of my rule file, and one of them looks for the word yes, and it uses these modifiers that say that it'll accept yes with the letters being either lower or uppercase, but it will only accept yes if it's a full word, which means that yes itself has to be a word on its own. It can't be part of another word like yes sir or something like that. It has to be a word on its own. And then I also made a no rule. And then the no rule basically does the same thing, but it looks for no in those same conditions. So then what I ended up doing is I wrote this program, and so here's my main function. So I go through, and I'm going to provide this this code on the website as well. So don't fret about trying to scramble to get it written down right now. But basically, I do all the initialization right there, and I explain what I'm doing for each step of that, and then I go to the for loop. And what this really is doing is it's basically a really simple chat program. So I'll type in information, and then if something I say matches one of the rules from Yara, then the computer is going to respond with a witty message of some sort. So the only rules I really made were looking for yes and no. So what ends up happening, I'll go back down here, is every time I enter a line of information, so every time I give it a line of information, the program then scans just the content of that line to try and see if any of the data within that line actually matches what I'm trying to say. And the way it does that is it runs that scan function you saw below, and that scan function calls this callback, which I passed as a parameter to it right here. So it calls this callback function multiple times throughout the execution of that function. So before the function returns back here and then goes back to the top of the loop, it actually calls my function a number of times to handle different scanning events that occur. So in my callback function, what I do is I look at this message, and the message is a different value based upon what my scanning event is that I'm dealing with. The only scanning event I care about is when one of my roles matches the input text from the user. So I put this big if statement. It's the only one for that case, for that particular message rule. After that, I get the rule hit out of this message data structure that's right here, which is that data structure that I showed you on the slide here. This one down here above the cat pic, that is the data structure that you're dereferencing over here. And basically, I do a string compare on the identifier to find out which one of the rules it is. So if they say something positive, something that contains the word yes, then I say, how nice of you. And if they say something negative that has the word no in it, I say, well, never mind then. So it allows me to chat back and forth with the computer. So for instance, I can say hello, and it doesn't say anything back. But if I say, like no way, then it says, well, never mind then. So, and the important thing here is all this logic, all this program flow is actually controlled by the Yara rules that I've built. So you can actually create systems that allow you to do really complex like state handling and stuff like that. You can build more complex systems out of this tool than just that little simple command line utility that you were looking at before. But if I say no, it doesn't detect it because of that full word match criteria that I required. And then I can just close the file handle, which ends up getting detected right here with the EOF, and then it just breaks out of the loop and returns me back. Since I'm running this from the command line, I didn't do any destruction code or anything like that, but just that you're aware, if you use this ever in a kind of broader context, all of these functions are actually doing a malloc under the hood to try and allocate space for data structures and rule trees and stuff like that. So just be aware of that, and you may need to implement cleanup code under the hood if you end up reinitializing the compiler multiple times throughout your program run. So, but that's kind of a really simple example of something that's not exactly a malware checker, but it's just a more general purpose program and how you can use this tool to try and solve problems with it. So hopefully, in doing any of your like security research or any of that stuff, you might actually find applications for it outside of just scanning large directories full of malware. So the other thing that's nice is that libyara is also implemented in a Python API. Generally, it's distributed as a separate Python program, or I should say a separate Python package, separate Python module. So what I usually do is I end up installing it using the pip tool. Unlike the C API, you don't need 4 function calls in order to initialize it. It actually does a lot of the work under the hood. The other thing that's nice about this is that if some of you are familiar with Python and the modules, like you've used it for other things before, there's a really popular module called RE. Whoops. Yeah, here we go. And it's not related, or I should say it's not directly related, although it shares concept with the Google project I showed you. But it's not based on that at all. It's actually PCRE, or Pro-Compatible Regular Expression Library. But basically, this allows you to go and search within a string for a particular regular expression pattern. So what they did was they re-architected the code flow a bit for Python implementation so that the Python calls actually look a lot more like the Python calls that people are familiar with in this module. So it basically makes a version of, it makes basically a matcher or a searcher that that behaves very similarly to another popular module in Python, which allows it to be something that can be maybe drop-in replaced with existing functionality in Python. It still supports, so you'll see that what this ends up doing is it just returns a list of matches. It actually still supports that whole like callback function concept. So I'll provide this as well. As you can see, since it's Python, it's tiny, so it doesn't take up much screen real estate. But I'm loading that file again right here. And then down below, you can see that I have that iterating loop across my input text. So I'm reading in one line of text from the user at a time. And then I'm basically doing this match and passing the callback function that's right here. So I'm still doing basically the same thing. I'm just doing it in Python now. So, oh, sorry, wrong version of Python. So, you know, so there you go, and then you can exit. So the same thing. Also, if I really wanted to, I could, you know, I could add a new rule in here. I'll just do this, copy paste. So now I've added a new rule. You know, hypothetically, I can make my program a little bit more powerful so that just modifying the rules, maybe, you know, I could actually have, let me go this again. If I wanted to, I might be able to actually put the responses in the metadata here if I really felt like it. So I haven't been doing that right now, but that would be an entirely possible approach. But for now, what I'll do is I can just do this, and then I can just kind of add another so, you know, I can just add like another response to it that way. So as you can see, I can kind of grow these things out. If I wanted to, I could build a mechanism that attempted to respond to users' you know, answers, and even possibly even jump around to different rules based upon different state tracking mechanisms and stuff like that that I would implement in a more complex program. But in the end, really what I'm doing is I'm using this thing as a pattern matcher to accomplish some sort of pattern matching work. So, you know, it doesn't just have to be about malware. It could be, you know, applying it to, say, search trees in like AI space or something like that too.